So remember that we always follow the same pattern when we're learning functional groups. The first thing that we learn is how to name them, and the second thing that we learn is how to make them. And so that's what we're covering next, preparing aldehydes and ketones. And good news, you already know all of the ways that your textbook covers for making aldehydes and ketones. So this is just going to be a review of reactions that you've already learned, kind of coming at you all at once. So you learned back in the fall, you learned, oh no, actually this was winter, primary alcohol. You can use mild reducing agent, PCC, always in CH2Cl2. Mild reducing agent converts primary alcohols to aldehydes. And you also learned back in the fall, so this was definitely in the fall, one of my top 10 favorite reactions. If you have an alkene and you do ozonolysis, step 1, O3, step 2, DMS. If your alkene has at least one hydrogen on the double bond, then one of the products of that ozonolysis will be an aldehyde. If you don't have any hydrogens on the double bond, then your products will be ketones. So the ozonolysis of an alkene makes either aldehydes or ketones, or both aldehydes and ketones. We also learned in the fall for alkynes. Now, not ozonolysis of alkynes, because when you do ozonolysis of an alkyne, it makes a carboxylic acid. But we learned addition, anti-Markovnikov addition of water across the alkyne. So that was something like, we could just abbreviate it, R2BH3. We used reagents like SiA2BH3. Step 2, because it's anti-Markovnikov, step 2 is always H2O2 in OH minus. So that initially adds one water to the triple bond, anti-Markovnikov. So we get this initially. That's an enol, alkene alcohol, and that immediately tautomerizes, rearranges, moves the double bond, moves the OH hydrogen, and we get an aldehyde. Remember, we learned in 241 that this enol wasn't isolatable. It would automatically turn itself right into that aldehyde. We learned same type of reaction adding to the alkyne if we did a Markovnikov addition to the alkyne. So this was kind of like hybrid reagents, H2SO4 and H2O, which we would use for Markovnikov addition to an alkene. But we also needed a mercury catalyst, HgSO4, which kind of reminded us of alkoxymercuration, demercuration. And that reaction initially would give us a Markovnikov addition of water, which is also an enol. And that enol immediately rearranges itself, moving the carbon-carbon double bond to become a carbon-oxygen double bond, and moving the hydrogen, the OH hydrogen. This gives us a ketone. And then we've got a couple more. We learned we could do a secondary alcohol, oxidation of the secondary alcohol using something like our book really likes to use, sodium dichromate, Na2Cr2O7 in sulfuric acid, H2SO4 with a little bit of water in there. And that's going to give us a ketone. And then last but not least, at the end of last quarter, we learned Friedel-Crafts acylation, not alkylation, but acylation. We need an aluminum chloride catalyst for this, and this is going to give us a phenyl ketone, or one of the R groups is the benzene ring. So those are the methods that we've already learned for synthesizing aldehydes and ketones.